Hello, my name is Ian Jaguar, and this is my programming project. After we've provided our user with an introduction, their rules choice, we have to take a couple inputs from them. And I accomplish this via 3 while loops, all based on the same variable known as valid from my code. The first one is collecting the color of the character, and it is only running when my valid variable is equal to 0. I use the same variable for the input as I do to actually in the code to call upon. And I accomplish this simply by redefining it. For the colors, obviously, it's got to be a 1 by 3 matrix. And then for the shape of the character, it's going to be either SO or D. It could have been anything else depending on what we were allowed to use. But for our circumstances, it's a square, circle, or a diamond. So I just renamed it as one of SO or D. I also make sure that they're not going to be able to put in any other choice by using this else statement at the end of each of these. Just if they provide a value that's not 1, 2, or 3, it's going to tell them invalid. Got to provide a real valid choice. So those are the inputs, pretty straightforward. If I jump down to the end of my code, we'll see this else here, and then these if statements within that are how I predetermine what move is and is not allowed, depending on what zone you're in. So if we are given that they want to move north, so our direction is our input for which way they want to move. If they say they want to move north, they provide 1. We got to check, are they in zone 1, 2, or 3? So if the direction is 1 and they are in zone 1, 2, or 3, we got to tell them not possible, can't move north. And then it's the same exact process for directions 2, 3, and 4. And at the very end here is this display, invalid choice, please try again. And this is for any value that's not 1, 2, or 3, or 4 that they try and put in. It could be another character, another letter, any of those cases. It's going to tell them you got to provide a new input. It's going to prompt them for new input. So for the actual code, let's go back up. There's a couple things we need to point out. The first are these plot fill values. So these matrices correspond to how I'm using the fill function. The W is for the wall, or in our case, also with the complete blackout of these. And I found the easiest way to accomplish the wall was just to fill the entire subplot with that one color and then put the path over top of it. So that's why it's so simple. It's just 2 by 4. It completely fills the whole entire subplot, and it made it easy for me to use just to redo the black. Now this P matrix is a 9 by 24 matrix, and the reason it's so large is because it takes all of the X and Y values for every single subplot for the path. So if you look at my initial plot, I'm calling upon P of zone 1 through 12 and P of zone 13 through 24. Let me break it down for you real quick. Zone is how I keep track of which subplot we're in. I call them zones. It's simple enough. So if I want the first row of P, because we're starting at zone equals 1, I'm going to the first row. I want the first 12 values. These are all of the X coordinates. Then I need the Y coordinates, so I call upon 13 through 24, or the second 12 values. And I do this to make it as easy as possible all throughout the code. It's this exact same setup for every single one of my movements, and it ensures that it's always going to be updated because I'm always updating my zone value. Lastly, I have these 3 values here, which are my move count, my column and row index, and the column and row index are for my actual plotting of my character in each subplot. Because I'm moving, I have to make sure that I'm keeping track of the X and Y directions, or coordinates for us, that the character can be placed. So for the movement, it's running in one big while loop. It's infinite. It's while 1. It only breaks if we find the key and we go back to zone 1, which we see here, and I'll explain the key in a minute. But if we look at the actual code, we'll go for a movement we can make. I talk about this direction here, and I have a Boolean to ensure that the direction they provide is possible. So if they want to make a movement to, or south in our case, the code has to see that, okay, they provided that, but are we in a zone less than 7? Because if we're not, we cannot make that move, and then it's going to skip down to the end. So if we are, now we get into this second if statement here. This if statement is for the animation. these y1 or yi1 and yi2 values change depending on which zone we're starting in. So if we're starting in zone 1, 2, or 3, we have to move from y5 down to 0 into the new subplot, and then from 6 to 3. However, if we're starting in 4, 5, or 6, we're actually starting at y equals 3, moving down to 0, and then going from the next subplot, and then going from 6 down to 1, because those are the resting positions, or the y resting positions. So that's how we accomplish that. Again, all based on our zone value, so that's very key to us. Next is our first for loop for movement. This is how we animate the character moving down. And it's going to be the same regardless of where this for loop is placed. It's the same as this one down here, except this one has a bit of a modification. But basically all I'm doing is I'm saying I want to take the subplot that I'm in, so 3, 3 in the zone. I'm going to turn the hold off. I'm going to completely fill it with whatever color wall we've selected. I'm going to hold onto that, and I'm going to plot the path over top of it. And then I'm going to put the character in whatever position it's supposed to be in. And since we're moving down, I want to update the y coordinate every single time. So that's why I have II placed here. The pause here determines how quickly we actually move. And so this will run for y1, yi1 in either case until we get to 0. Stops the for loop. We're at the end. Now we need to update our zone. Now the thing that I noticed is that when you move up or down between zones, you're actually going +3 or -3. Because if you think about it, 1 to 4, 4 to 7, or 8 to 5, 5 to 2. It's the same increment every single time. And it's the same setup as moving in the east or west or right to left. But instead of +3 or -3, it's +1 or -1. So I managed to figure this out, and that's how I generalized a lot of the zone plotting. So now I increased my zone +3 because I moved down. I want to turn my hold off again because now I need to plot everything in black. So I run this just the same as before. I'm taking each individual subplot and covering it completely in black. And now I'm ready to make my move into my new subplot. So now I call upon my second set of animation coordinates in the Y. I'm now in a new zone because I've updated it. I turn the hold off. I fill it in the color wall. I plot the path. And now I have this second if statement here. And this is all for the key. I'll explain that in 1 second, but this is all the same as before. It's just updating until we reach our end value for whatever we're stopping at, depending on where we are. I update my move count, and then because we're moving up or down, the row index has to either increase or decrease. If we move left or right, the column index has to increase or decrease, as seen here. So that takes care of our movement. Now for the key, we have to go back up to actually determine how we're placing this. So I found the easiest way for me was to make this depth matrix, which is an 8x3 matrix, and I randomly selected one of the rows, and that's how I randomly generate the key essentially. So the values in this matrix correspond to the x position of the key, the y position of the key, and the plot in which those x and y positions are found. As I said before, I randomly generate a number 1 to 8 that selects one of the rows. I take all of those values and then I correspond them to key x, key y, and key plot. As I said before, the first value is the x, the second value is the y, the third value is the plot. Lastly, I set key equal to 0, this meaning that the key has not been found or it is false in a sense. Key 1 would mean true, that we've picked up the key. So now we can go back to this if statement that we looked at before. So this is running perpetually, and it's checking to see if our key plot is equal to our zone and if our key is equal to 0, meaning that we haven't picked it up. If those two things are true, we are now going to plot the key into this new zone that we're moving into. Because remember, this is our third for loop. This is the one that we've moving into now. We're going to plot the key, and then we're going to also tell them, the player, you found the key, you found the key, you found the key. After that, we have to say, okay, well, we found the key, we landed on it, now we have to collect it. So after that for loop, at the end here, we say if key plot is equal to zone, the key is equal to 1, meaning the key will never be plotted again. We have to go back to the first zone to end the game, essentially. So now, once we go back to the first zone and our key value is equal to 1, meaning it's true, we've picked up the key. We're going to say winner, winner, chicken dinner, because you're a winner. And you're going to tell them how many total moves they've made to complete the game. And lastly, this whole while loop has now been ended, because we break. And the very end here, now we have to do the random colors. And this is achieved by a nested for loop. So the for loop that's inside of this runs I equal 2 through 9, which is zones 2 through 9, because again, we want to keep zone 1 open. We want to just see our character. And we're going to do the same thing as if we were making them all black, essentially, except now we're using rand 1 to 3, which makes a random color matrix. We're going to provide a pause after that to make it go individual. And then we need this to run 3 times, so that's what the other for loop's for, and we have a pause there just to make it stop after it runs. Real quick, real brief. And there's that. So that's how my code works, and I think I did it pretty efficiently. So thank you.